Okay, guys, this is going to be the culminating video of electric charges. Yep, we're going to do some math. Okay, and I think this is probably going to be, maybe the more simple part for you guys because it's just a little bit of algebra here. Again, videos are best played at 1.25 speed. Google tends to slow down my voice. So, what we have here is our new equation, Coulomb's equation. We said that the force. Now, yeah, that's actually force. That's like, in newtons. The force felt between two electrically charged objects is equivalent to Coulomb's constant times charge 1 times charge 2 divided by their distance squared. Okay, so let's look at this in terms of what it actually is. So, like, let's say I'm going to look at number 23. This is on page. So this is number 23. You may be wanting to follow along, but page 76 of the notes. And the cool thing is, in the corner of that, you can click on it and get an explanation from somebody at New Jersey. I think I do a better job, but well, let you be the judge of that. So look, okay, it says this in number 23. If you would turn to that page in your notes, it'd be great. If not, let's follow along. So it says that you've got a couple of charges here. Now, here's the deal. Here are your surfaces. So, like, here's a picture of it. Okay, this here is the radius between the two charged objects. And what it's saying is that there's a positive 20 micro-Coulomb charged object here at this point, and then there's another one that says it's negative 40 micro-Coulomb charge here. Now, guys, all it wants you to do is, first of all, these two are attracted to each other. Okay, they're going to pull each other towards each other because one's positive and one's negative. So look, this has a positive charge, this has a negative charge. We know they're going to pull towards each other. So we want to know with what force here these things are going to be pulled towards each other. Okay, well, it gives us a few things. Let's call Q1, this one here. Let's call this Q1. Let's call this Q2. It says Q1 is 20 micro-coulombs. Okay, it says Q2 is negative 40 micro-coulombs. Okay, it also says that the radius, this is tricky, the radius is 20 centimeters. Okay, now, so if this radius is 20 centimeters, well, let's see what we got. We got a radius, we got Q, we've got Q, we've got K. Remember, K is 9 times 10 to the 9th. And we're just going to, we'll leave the units out to avoid confusion. That's the K value. That is our fudge factor that we plug in there. Look, we got everything we need, but we got to kind of clean it up a little bit. So, to clean it up a little bit, okay, what I'm going to do is I'm going to put some arrows here. So 20 micro-coulombs, all that means is it's 20 times 10 to the negative 6. Remember, micro means negative 6 coulombs. We know that 40 is 40 times negative 40 times 10 to the negative 6 coulombs. Well, hey, look, they got us here too. So centi, we can either use our knowledge of centimeters versus meters. This will be moved over twice. Or we can realize that 20 centimeters is equivalent to 0.2 meters. And this here can stay the same. So now that we've got everything kind of cleaned up here, we can do the math involved by using our one formula that we have. Okay? So using the one formula that we have, okay, I'm going to try to make some space here. The force felt between these two objects is going to be written as 9 times 10 to the 9th. That's our K value. Q1 is going to be 20. I may run out of space here. I'm going to have to move this over manually. Let's see here and hold on to it. All right, 20 times 10 to the negative 6th. Okay. Coulombs times negative 40 times 10 to the negative 6th coulombs, all divided by 0.2 meters squared. Okay, so I'll leave that up for a second. The force felt between these two charged objects is our K value, Q1, Q2, divided by R squared. Okay, you may want to pause it here because I'm going to pause it, do the work, and I'll come up with a force in newtons, okay, for you. Okay, if my math is correct, okay, what I've got for this one, I'll move it over a little bit, is that the force that you're getting here after doing all the math would be 180 newtons. Okay, so after doing all the math, you would get 180 newtons of force is felt between these two objects. So look, an electric force, electric charge, can be solved if you have the two charges and the distance between the two. So just like gravitation, as these things get farther apart, the radius changes. Then so does this change. Okay, so you're going to have to kind of look at that relationship. As this gets bigger, the distance gets bigger, this force gets smaller, and it's actually by a factor of 4. Okay, so that's the one problem I'm going to show you guys. I trust that you'll be able to do the algebra. It may ask you to solve for one of the forces. It may ask you to solve for a radius. Okay, so you should be able to transfer this into its different forms in solving for charges and for radius.